Hello, and welcome to this WATS introduction. In this broadcast, we will explain the concept of test data management for manufacturing of electronics and how you can increase yield and deal with quality issues that occurs during the process of building your products. We will start off with a few slides, and then we will go to a live demo. This video will be posted on our YouTube channel afterwards, so if you want to revisit the broadcast or would like to share with one of your colleagues, you can do it from there. You will also be able to ask questions. Just access the chat feature in GoToWebinar, and we will answer those by email afterwards. So there are many reasons why you want to use the data from test. Manufacturing of electronics is prone to errors, and they can occur in your components, in your processes, in your test instrumentations, and so forth. So having access to the data and understanding what's wrong can help you address these. Then mass production or production of critical components increase your risk associated with failures in the field. It can be warranties. It may hurt your brand name, your sales. And many manufacturers have outsourced the manufacturing. That could yield in longer time to identify the problem. And of course, it will be more costly. All companies that we've been working with have seen significant potential for improvement. We encourage you to collect data from all processes in order to find issues as early as possible. That will have the biggest impacts on your cost savings. This is also called the 10x cost rule. So typical problems that WATS help you address. First one, being able to get data from all kinds of formats like databases, custom formats, binary formats, and so forth. You can also collect data from manual processes that are normally stored on paper. Data stored in multiple locations, so your setup may include contract manufacturers all over the world. We help you get this data in real time and at the same time being able to negotiate the different types of network topologies that are out there. A big thing with this data is that it's normally used retroactively. For instance, after you've had a field return or a problem, then you go back into the data, which is normally then a manual process and very time consuming. So in WATS, we want to make sure that you have the data available in real time so you can address the issues before it hurts you financially. If you have new products or new revisions in your system, they will automatically show up in the portal. There is very little configuration. So all in all, let your talent focus on your own business and use an off-the-shelf tool like WATS to address the data that you store in your test systems. So what can you get out of the data? There are statistical information that we calculate, for instance, first pass yield, CPKs, etc. There are methods of doing comparisons of the different sites, the different revisions, test stations, and so forth. We can help you understand the limits that you use in your numerical tests. There are Paretos available, so you see what causes a sequence to fail the most or what takes the most time. We encourage you to enter repair information so you can have a better view of the root cause. There are tools to see the historical information, and you can also set alarms that you can have the system notify you if something goes wrong, and you can connect to other types of enterprise systems that you may already use, like MES, ERP, and dashboard tools, etc. Okay, so then we will switch to WATS. We have an instance logged into. So in WATS there are three main applications. There's an operator interface where you can add your repair reports or you can perform manual inspections. There is a control panel where a super user will give users access to parts of the system, so you can define processes and you can define the virtual levels of your manufacturing. And then there's the reporting, where we would concentrate this presentation on, where you access the data and you do analysis and being able to understand what's going on. So let us open the reporting tab. The first thing we would like to do is to just run the simplest form of analysis. We're going to do a UUT report to see the individual test reports stored into the system. It's found in the test and repair menu on the left-hand side. There are two reports available. There's a preview of the next generation. We're just going to use the current one. And the way we would access the information is by filling out this filter. So if you have defined product groups, you can select a product group. So a product group is basically a collection of part numbers and named with an understandable name, so you can sort them more easily if you need to. There are also a level showing your setup, like this, where you have a contract manufacturer, Mexico, factory 1, cell 2. You can define this as you please and use them to better distinguish between the different sites or product lines that you have. You have, of course, serial number, part number, revision, and then over here we have a test operation. These are essentially the different processes that your manufacturing consists of. So in this example, we're going to use data from our PCBA tests. And we're accessing data in this time span. So by hitting apply, it will then collect data from this time span, reports that are linked to the PCBA tests. So here I get a list of all the reports. There are 3,900 reports being returned, and they are listed by serial number, the status of the overall report, then the part number, revision, when they were tested, and so forth. So I can open one of them. I can open up a past report by clicking this magnifier glass. So it will load the complete test report, and on the top I will have the meta information, like the part number, the revision, and so forth. And then at the bottom I will have all the test steps listed. I can click this show hide all to expand all the different results. Just have a look at this report. We can see all the measurements. We can have a look at the one over here called the reset delay. We see the measurement 254.7, and the limit were 150 and 325. We have the units, the comparison type, and then the step status, which is in this case is passed. So these are the simplest types of reports. They're one by one. And then next we can have a look at over here are the yield reports. So the yield reports will give me all the different products being tested and divided by part number, revision, and so on. I'll click the yield report. And at the same time, again, we're just going to run a very open filter asking for all the PCBA tests in this time period. If I click apply, I will get a collection of all the part numbers that have been tested in this period. So the top one, OLC 140C, PCBA test, 1,371 products tested, 1,054 passed the first time. And then the yield calculation is 76.9%. So if I want to investigate further, I can go to the next level, which is basically in our system called test step yield and analysis. So the filter will be populated by the data from the field that I chose, which is this part number, OLC 140C. There are two different rows with data containing two different software versions. So I can do one of them. I can do the software version 160, which has 834 units. If I hit apply, it will now analyze these test reports and give me timing information, what takes the most time in these test reports. So there's one here called Island Configure that takes up 77% of the total time, which is quite a lot. And then it will give me my top 10 failures. So my top 1 failure for this product is a test called Power Load that failed 65 times and counts for 29.5% of all the failures. The second most failed test is one called Reset Delay. It has 51 failures, and those two combined are 53% of all the failures for this product. So it's a good place to start if you want to increase your yield. To go to the next level again, I can click on this bar to have a more detailed view of the power load test. So now it loads the step details report. And it will give me a lot more detailed information about this test step. So on the top, I can see a pass-fail diagram showing me when throughout this period the product passed or failed. So for this case, it has been failing pretty much throughout the whole period. So it's a problem that I still have. Then at the bottom, I will see the detailed measurements. So this blue line indicates all the measurements. And I will see here on the red line my high limit. And the bottom red line is my low limit for this test step. As you can see, all the steps are failing against my lower limit. So either the test results should have been higher, maybe the measurements should have been up here, around 13 volts, or the limits are set incorrectly. I also have access to a lot more information in here. I can move my cursor in this data and I will get the detailed information about the serial number, the measurement, who tested it, and so forth. And I can click here and it will open up the complete test report for this product as we saw earlier. But in this case, where it is a failed test, it will also expand on that test step and will mark it like this. So I can see the measurement is just below the limit set by this attribute. You also have ways of group your data. So if you want to group it by station name, fixture ID, socket index, test operations, to see the variations over different assets or fixture IDs, etc., you can do that by changing the group setting. You can also look at the data in various ways, like a box plot. So if you have multiple assets, you can see a box plot per asset. What is a time plot, showing you in which time period did you make the test reports. So here you can see there are certain time periods the product had been tested. So in June, July, October, November, and December. This is a typical way we access the data, and where you are able to see the details and kind of assess what's going on with this test. Okay, next example, I want to look at periodic yield. And the periodic yield will give me information about retesting. So go back to my main window. I choose periodic yield under the yield reports. Take out this from the filter, so it's pretty much open filter again. I'm just gonna look for PCBA test in this time period, and I can select the grouping that fits the time period. So from hour to year, I have a year worth of data that I'm asking for, so a monthly grouping is fine. I hit apply, and the system now will retrieve a grouping by month. I will have a total count per that time period, a pass count, and a yield calculation for that time period. So we can have a look at July. It has a very low yield calculation. I can expand July, and it will now show me all the products built in this time period. So I have 4 different products. You can see their individual count and their pass count and their individual yield. We're here. Okay, but when I do this, expanding one of these rows, what we also can see at the bottom of this report is information about my retest. So above, I saw that I had 482 out of 699 products that passed on the first run. But here I see, moving my cursor on top of these bars, I see that I have 168 products that passed in the second run. I have 15 products that passed in the third run, and so forth. And I even have 1 product that passed in the 11th run. I can then also click on these bars, and it will give me the detailed information about these serial numbers. So it loads a report that we call serial number history report. And it will show me all the reports being stored for the PCBA test for this serial number. So this is the serial number under question, the part number, and then the 11 test reports. So I have 1, that failed July the 30th, 07:07 in the morning, and then another retest 7:08, and then failed reports until it passed at 10:26 after 11 test runs. It could be perfectly fine, but there is no repair information in here, so I don't have any information about what the operator did to make it pass in the end. But this periodic yield gives me a very quick access to all the retest in my system. The last thing I would like to show is what we call process capability analysis. So I'm going to clear my filter, and I'm going to access one of my predefined data sets. I hit apply, and it will retrieve a list of products again. Here I have all the products I built in this period. I'm gonna look at the top one called OC140C. I have 1,400 of those, and hit apply. And then what we do here is that we calculate CPKs for all numerical measurements being used to test this product. So I get the list of the step names, and then on the first column I can see the CPK if it's available. A CPK is basically a measurement showing me how well my data fits the limits being used for that particular test step. We mark the ones that are below 1.32 red, and this means that the measurement being returned doesn't really fit the limits being used. The one in green are values between 1.32 and 4. Here the limits fits well, and then we mark blue everything above 4, indicating that the limits may be too wide for the data being used. The one with the widest limits in this case is one called oscillated test, and has a CPK of 10.29. If I click my magnifier glass, view details, unit view, it will show me how this data looks like. It will show me the actual data being returned from that test with the test limits being used. So I get first a preview. I see my limits, my high limit, I see my low limit, and I can see the data variations here in the middle. So there are plenty of room for outliers here with products that are outside of the normal distribution, which may be a problem if they are. So by using this process capability analysis, I'm able to find these issues. On the fifth column, we also calculate CPK without failures. So we take out data that may impact the measurement or the calculation, and then show you the new calculation. So there are some down here. For instance, test IO1 read back low. The measurement is 0. Or the CPK calculation is 0.23 with all the data, but it's 706 when we take out the failed units. So let's have a look at this one to see how the data looks like. I click the details view again. It will load the preview as before, show me all the data with the limits. Okay, in this case, I'm going to click the Analyze Selection button, and it will open up the detail view, so we can play around with the data a little bit more. Okay, so here's the data loaded. I can see my high limit, I can see my low limit, and I can see when they fail, they go off the chart. So let's push this button called Failed Measurements here. And we click it to hide the ones that are failing. And now we can see a new view. We can see the high limit, we see the low limit, but we see the data variations plus a few outliers that are clearly outside of the normal distribution. So these have then a question mark. Should they really pass this test? But in this case, with these wide limits, they are passing the test. So by using the process capability analysis and look at the difference between CPK calculation and CPK without failed, it can give you this type of, or it can help you locate these test steps that should be investigated for limit issues. Okay, so that was some of the examples. You can learn more by signing up for a demo at skywatts.com. You can also get a presentation. If you would like to have this explained on your own data, we can help you set this up. Thank you for joining me today. Test data management is an extension of your test system. There is a lot of value in the data that can help you increase yield, decrease failures, and then increase your quality, profits, reputation. So please sign up for a trial and see if we can help you get started on analyzing your data. Thank you.